Okay, pre-cal. Next set of notes, proving inverses by composition. Whatever do you mean, Miss Griggs? Well, in 1.6, we talked about composition. And just to refresh your memory, remember if I've got f of g of x, we can also write it f with this little symbol of g of x. That's what it means. So why are we going to use compositions in this way? Well, the nice thing about compositions is that I can use them to see if two functions are inverses of each other. So, for instance, if I've got f of x and g of x, if I find f of g of x and g of f of x, if these two compositions are both equal to x, then I know that they are inverses of each other. So let's see what this looks like. All right, so I'm going to find f of g of x, and I'm going to find g of f of x. If they're both equal to x, I'm golden. All right, so what does this look like? Well, if I've got f of x, which is 3x minus 4, I'm going to replace the x's with g of x. So that means I'm going to have f of x plus 4 over 3, because that's g of x, equals 3 times x plus 4 over 3, and then minus 4. Okay, well, what happens here, this 3 is understood to be over 1. And this 3 right here is clearly in the denominator, so those will reduce with each other. So now I'm just simplifying. I've got x plus 4 minus 4. Those add to 0, and this is x. So f of g of x equals x. Score. Now all I have to do is find out if g of f of x also equals x, and then I can say that those are inverses of each other. Okay, so g of x is equal to x plus 4 over 3. So I'm going to replace these x's with f of x. So g of f of x is 3x minus 4, and in my fraction, I'm going to replace that x with 3x minus 4. Okay, so everything else outside of this highlighting here is normal. Just 4, see this 4 right here, this 3 right here, and then I replace the x with 3x minus 4. Okay, so now I'm just going to simplify this algebraically. In my numerator, notice that negative 4 and positive 4 add to be what? 0. So I end up with 3x over 3, and look what happens to my 3's. They reduce. Groovy. Now, kids, a lot of you are going to be tempted to skip all these algebraic steps because you're going to look ahead and see that it works. Please don't do that, because no work gives no answer. Are you with me? Okay, so f of g of x equals x, and g of f of x equals x. Guess what that means? F of x and g of x are inverses of each other. Awesome! In other words, if I were to find the inverse of f of x, it would be what g of x is. That's neato. Okay, so I'm going to do the same thing over here, and I'm going to skip some steps. So pay attention. So f of g of x is going to be f of x over 4 minus 2. So in f of x, I'm going to replace the x with x over 4 minus 2, and then plus 8. I know it gets a little convoluted, but okay. Please be careful. This 4 gets distributed to both of these. If you don't do that, you're going to get the wrong answer. 4 times negative 2 is negative 8. These reduce. I end up with x minus 8 plus 8. These add to 0. F of g of x equals x. Groovy. Let's see if g of f of x equals the same thing. So look at your function. We have x over 4 minus 2. The x gets replaced with 4x plus 8. Again, please be careful and pay attention, because this fraction right here can be written as 4x over 4 plus 8 over 4 minus 2. These reduce. These also reduce. And look, these add to 0. G of f of x also equals x. So guess what? F of x and g of x are inverses of each other. Magical! I knew you'd be excited. Okay, I know this video is going to be kind of long because we're doing all of these, so I'm so sorry. So f of g of x. See, the more you do these, the better you'll get at them. So f of x now becomes g of x. Well, g of x is the cubed root of 8x. Okay, so remember, f of x is x cubed over 8. So the x gets replaced. So this x gets replaced with the cubed root of 8x, and that gets cubed. Okay, so be careful. I know it's confusing, but you can do this. Okay, babies, think about this. If I've got, think about what we did in our equations a minute ago. Remember, we had x minus 7 or something, and we squared it, and what happened? The y minus 7 came out. Okay, remember that? Okay, we're going to apply that concept to this right here. So if I've got 8x, I'm taking the cubed root and I cube it, guess what I get? I just get 8x. And then over 8, those reduce, it equals x. Groovy. Now I'm going to find g of f of x. What does that look like, Miss Griggs? Well, I know that I'm going to replace g of x with f of x. Well, if f of x is equal to x cubed over 8, that's what I'm going to have. Now, your g of x is the cubed root of 8 times x. But instead of x, I put all of this. X cubed over 8, just like that. Okay, so we're going to simplify inside our cube. So the 8's reduce because this is understood to be x over 1, and I end up with the cubed root of x cubed. What is the cubed root of x cubed, Miss Griggs? It's x. Look at that. F of x and g of x are inverses of one another. Yay! Or of each other, whatever. Okay, let's do this last one right here. Okay, so I've got to find f of g of x. Well, f of x is 12 minus x. So what goes in for x? G of x. Kids, I cannot emphasize this enough. Please distribute your negative. It's 12 minus x. This positive x becomes negative. Please be careful. 12 minus 12 is in fact 0, and we get negative x. All right, we need to stop right here and pay attention. Kids, is x the same as negative x? Now, a lot of students will ask me something silly here, and they'll go, well, what difference does it make, Miss Griggs? X with a negative in front of it is still the same thing as x. No, it's not. This is clearly different from this. So I'm going to ask you this again. Is f of g of x equal to positive x? No. F of g of x is equal to negative x. We don't need to go on. Because remember, in order for f of x and g of x to be inverses of each other, f of g of x and g of f of x must both equal negative x. Well, if I've already found that f of g of x equals negative x, guess what? I already have the answer to my question. Now, I'm going to prove it to you. G of f of x. So if I were going to find g of f of x, well, g of x is 12 plus x. I'm replacing that with 12 minus x. Well, here you get 12 plus 12, because when you distribute a positive, nothing changes. 12 plus 12 is 24 minus x. Again, is that equal to x? No. So guess what? F of x and g of x are not inverses of each other. Neither one of them equals x. F of g of x and g of f of x g of f of x and f of g of x, neither one neither one of them equal x. Sorry.